However, precedent doesn't work so well when there is significant change, like changing the geometry of the basketball court, the rim, and the ball. And we're not playing a game. We are providing the essential needs of civilization. Why does it matter? Significant changes will be needed now, soon, in how we provide water, energy, shelter, transportation, and waste management on Earth and beyond. If we do not adapt, the systems society depends on will be in peril. If we do not take a leading role in the transformation, we will not be fulfilling our responsibility as engineers to hold paramount the health, safety, and welfare of the public. What is our goal of this summit? The purpose of this summit is to get in front of the disruption instead of reacting to it. We have brought together thought leaders, you all, problem solvers, and innovators with a wide range of perspectives. We want to spark ideas about the future, identify emerging challenges, and begin charting a path forward. Why is UT Austin hosting this summit? The Fariborz Maseeh Department of Civil, Architectural, and Environmental Engineering is honored to host this summit. 8 years ago, the American Society of Civil Engineers inspired us about the need for change with their Future World Vision initiative led by Jerry Buckwalter, and it got started with the help of Pat Natal, who is here. 4 years ago, we inspired Fariborz Maseeh to invest in our department to help lead our profession in this transformation. Fariborz understood that our department is large and well-regarded, meaning changes we make will be impactful. 3 years ago, Don Roos joined us with an expertise in strategic planning to figure out what changes we were going to make. We quickly realized that while we could not predict precisely what was going to change and how it was going to change, we were certain we needed to produce students who were adaptable and ready to lead changes. We are currently overhauling the first 2 years of our curriculum by integrating 5 separate courses into a sequence that captures the art of data science, visualization, simulation, systems, design, making decisions with a variety of stakeholders, and communicating decisions with broad audiences. The emphases throughout this arc are critical thinking, creativity, and ethics. The format for these courses is coached learning that will include a mixture of lectures, asynchronous modules, problem-based activities, and projects similar to Olin College in Massachusetts. We also realized that the transformation was far bigger than us, and even our profession, and thus the idea was hatched for hosting a summit with thought leaders from a variety of perspectives. 2 years ago, Fariborz Maseeh encouraged our alumni to follow his lead in investing in our department to help lead our profession in the impending transformation. The first one to step up was Dick Wade with a $50,000 check that is helping cover the cost of this event. Transformation is inherently disruptive. The inspiration for the title of this summit was a disruptive technology workshop that our electrical and computer engineers organized several years ago. They were talking about the disruption associated with having your microwave connected to your phone. We will be talking during the next 2 days about transformation that is big, impactful, and deeply human. What starts here changes the world. I would like to thank our sponsors, the United Engineering Foundation, led by Pat Natal, and Engineering Change Lab, which is led by Kyle Davey. I would like to thank the organizers of the Disruptive Innovation Summit, Manish Kumar, Jerry Buckwalter, Don Roos, and Kyle Davey. I would like to thank the 9 incredibly talented speakers who are setting the stage for our discussions, and you've already gotten to see 2 of them last night. I would like to thank the 8 professional facilitators who are volunteering their time to help us with this because they're excited about the topic and they're really excited about the audience that they're going to be working with. And I would like to thank all of you for coming to Austin to participate in the Disruptive Innovation Summit. It's an honor and a privilege to host so many bright and creative leaders. I look forward to listening and learning from your varied perspectives. Jerry Buckwalter will now explain the larger context in which this summit resides. Thank you.
Thank you, Bob. In the spirit of our first guest, I'm going to simply tell a story first. Bob referenced the Future World Vision as one of the starting events, and I'm going to describe how the ideas for these things we talk about today, the questions that we ask started 20 years prior to that, often from outside your industry who can see better change coming to your industry than you can. So let me give you an example of that, if I may. My career has had a very meandering pathway. I've had several different ones. For the predominant portion of that time, I was an engineer for the government, mostly the military and the intelligence community, and for the companies that do that kind of engineering work. I had the good fortune of being at a company that took cutting-edge technology and put it and applied it into engineered solutions that were very different than what you all work on. However, those solutions came from asking different questions. And those questions arose from doing in-depth analysis of potential future phenomena, 10, 20, 30, 50, 100 years into the future. For instance, a couple examples, if I may. In the 1980s, the question was, can we develop a totally autonomous jumbo jet-size aircraft that can fly above the radar-controlled airspace of any nation in the world, free to roam about and monitor every imaginable signal, emission, and image, and land back in the United States with no pilot in the plane or remotely piloting it from the ground? And we did that. And it actually went operational in 2001, a long time ago. In the 1990s, the question was, can we develop a stealthy long-range bomber plane that can fly around the world in radar-controlled airspace with a radar signature that would be less than what a moth would produce on a radar scope? We did that. And later on, a second generation of that plane was made where the sensors of the plane are not separate sensors and installed afterward. They are actually part of the structure and skin of the aircraft. Something we should think about because it's coming for civil infrastructure. In the 2000s, the question was, can we have high Earth orbit satellites, each seeing a large swath of the world at any one snapshot in time, but have an image resolution that could identify the number on a car's license plate? I'll pass on that. Who knows if we did that? In the 2010s, the question was, could the internet traffic of emails, website clicks, and social media be monitored with what we now call AI and let us know of any chatter indicating an imminent revolt or uprising or fight for independence in any non-US country in the world with a 3-day notice of a tipping point event, an overthrow, if you will? We did that for the first time when we notified the President of the United States that Assad would fall in Syria in 3 days, and he did. These are amazing kinds of questions that are different than what was normally posed to us as a military contractor, and it led to breakthroughs. But it only came because we looked deeply with plausible future scenarios, if you will, and then thought about the new questions we had to ask ourselves. Now those analyses that were done prior to those questions, and as you can imagine, have never seen the light of day. But that's when I realized, with some prompting from some fellow engineers, that everything we were looking at had equal dramatic implications for the civil built environment. And civil engineers, this is 25 years ago, were not discussing this. And the change was racing toward them, and they were generally unaware of the huge transformative impact of that. Hence, I started my second career. I came to ASCE. They were kind enough to help me, and with a large team of people, get started with Future World Vision. That's the kind of arc that you should be thinking about over the next 2 days. What are those questions that are that different that you would be asking yourself and would be obvious to you 20 years from now? When I said the Future World Vision, that's exactly as Bob said, and it's not advancing. There we go. We're good. And that was the conclusion. That was one of the slides that came out of Future World Vision. Jane will recognize that, right, Jane? Jane crafted many of these slides in its original form. But guess what? As Bob said, that was 2018. That analysis was 2018. We were talking about 10, 20, 50 years in the future, and so much of it's already here. That's what we never get right, the timing on these things. As Bob said, that turned into a transformative effort here that he just described to you with Fariborz's help and the redesign that he talked about. This summit is part of what UT Austin is doing to help promote this pathway that we are on. As he said, this is the challenge of the day. By the time we come away, we want to have fostered a different focus on innovation than what you normally do when you go back to your day jobs. We want to prepare for the adaptation needed, and we want you to feel inspired to have the courage to think about really nearly intractable problems as we view them today, because they're not. They just appear that way today. That's the format. There's the many sponsors. Bob already highlighted UEF and ECL, so I won't do that again. But I'll just look at the lower box. Keep this at the forefront of your mind through the 2 days. You are engineers. I know you will all dive right into the potential solution. I'm warning you right now. Breakthrough thinking first. You are all smart, well-experienced people. You will go solve those problems. Today, we ask the different questions. That's the format of the next day and a half before we do a panel session at the end. So you'll see some of the two speakers that will follow me this morning. The space-oriented discussion of this afternoon to draw out a discussion of the tools and equipment that we now have that we can use. And then we're going to get to how to become more entrepreneurial, innovative, and finance that in a different way. So this is not just about the technology piece. We get a lot of that this afternoon. We get a lot this morning of just reframing how you think about it before we even start that. And then we end with something engineers are uniquely not good at, which is talking about how we start new things, how we become entrepreneurial, and I hear all the time, and how we get, capital market money instead of, and we talk about we never do it well, but there are people who do it well. So that will be the sequence of your 3 topics as they flow through each half day. Don't need to do this and spend any more time on it, but that's what we want to take away from here. We actually want new ideas. We hope that some of the ideas actually reframe some of the R&D some universities might choose to do, for instance. And as you can get a feel, as maybe you did last night, we want you to be in the room with people from very different perspectives. We have people from insurance here. We have finance people. We have engineers of every stripe. We've got some government leaders. This is about building relationships among like-minded, forward-leaning people, because you will need all of you in support of each other if we are going to create the spark of change that we hope comes from this. And with that, I'm going to turn it over to Kyle so he can give you some feel for the ground rules of the day, and then we'll get to our speakers.
All right, good morning all. I'm Kyle Davey. Met a bunch of you last night, know a number of you in terms of longtime associates, so pleasure to be in the scrum with you for the next 2 days. And it really has that characteristic that what we're hoping to do is get, each of you working with all the others in terms of generating these ideas, asking those great questions that Jerry was referring to. The overall, arc of the work that we're going to do, I would characterize as a deep U. This is an idea that comes from Peter Senge and Otto Scharmer. They're organizational theorists from MIT, and great sort of thinkers about leadership. And they noted with regard to social change, what you should do, the approach you should take isn't the typical way we do things in Western society, which they, you could think of as ready, fire, aim. And think of that as a shallow U. Do just enough learning about the thing in order to have some idea and then go out and implement it. But of course, often with unexpected consequences, with misfires. Rather, they suggested, take a deep U approach to organizational change, social change. And I would say the work that we're involved with here, as you come down the U, you spend a great deal of time sensing what's going on in that social system. Really trying to, hone your ability, your perspicacity to, pay attention. What's going on out there that, given our normal blinders that we live with, we haven't noticed? So this sensing process, then as you come down in the bottom of the U, you make sense. What did this mean? What are the possibilities? Begin to allow the emergence of opportunities and ideas. And then as you come up in the U, you begin to have, action items. Let's try this. Let's make that decision. So that's the arc of the work that we're going to be doing over these 2 days. We'll spend a lot of time sensing, and we'll do the sensing in 2 ways. One, the benefit of this great roster of presenters that Jerry and Bob have lined up and Don have lined up for the program, who will offer their sensing. What do they see going on in their part of the world? But we'll complement that by workshops that we'll do after each one of those segments that Jerry showed the slide of. And in those workshops, we'll be trying to capitalize on the group genius that's present at your tables, but also in the, convened group. That group genius, what are you sensing? Then as we come down in the U, again, the presenters will offer some of their ideas about how to make sense of this. What opportunities exist, but again, group genius, what do you see as those opportunities, particularly as we ask and answer those great questions? So that's the arc of the program. We'll have presentations, then we'll have workshops to engage all of you. Next set of presenters, et cetera. At the end of the day, on the second day, we'll begin to pull together what are the key insights that have emerged over those 2 days, and those will be then offered in a final panel discussion that we'll do on the afternoon of tomorrow. So rough agenda. The agenda is part of the handout. Hopefully all of you have got a copy of the workbook. We'll be using that to sort of, pace the work throughout. It also includes the agenda and placemakers for you to take your own notes as we go through this. Now, some ground rules. Fairly typical for meetings like this where you're trying to generate ideas, be fully present. As hard as that is in the world of cell phones, be fully present. If you can manage that, be curious, ask great questions, the questions that Jerry was offering. Have a ground rule about confidentiality. Particularly stating that is we want to make it safe for people to tell the stories that embody those great lessons or those great ideas, but we want to have a ground rule about confidentiality about those stories. Not about the ideas that come out. We want you to use the ideas, the innovations, the possibilities, but if Manish tells a particular story that has some emotional content, and he's somewhat vulnerable telling that story, we want to have that sense of confidentiality about that. We're not, that doesn't go outside this room. A sense of, be honest and respectful with each other. particularly this idea of respect translating into, seek disagreement. See disagreement as a source of creativity. It's okay to disagree, it's just how we go about doing that. So that idea of constructive disagreement so that we can generate that creative thinking. Be open to inquiry, really, a classic thing coming out of, the learning organization theories. Question your assumptions, hold them up, inquire about those things as a source, again, of creativity and insight. And then Jerry's and Bob's counsels, think big in terms of what we're trying to do there. Anything else that any of you would add to this?
Kyle?
Yeah.
So since we are recording, it would be better to use...
Oh, I'm sorry, to stay on the...
You can take it off.
Yeah, no. I'll stay here. For now, we'll get the lavaliers working.
I'll add one, Kyle. Have fun.
Thank you. Should have been on the list, but only for Allison, because... Okay, have fun, and I think there is, particularly as we get into the idea generation space, the idea of being playful, with these ideas, not thinking that we're trying to craft this solution that has an absolute logic stream or adheres to some algorithm. This is, have some fun, connect things that haven't been connected before, have that sense of play. So thank you. Anything else?
May I suggest try to be specific where you can and nuance where you can.
All right, yeah, so if you can, if you can do that specificity, which would allow what? Others to bridge off your idea. Being a little bit murky or being a little bit too flowery in your language may not allow the type of bridging that we want and the lateral thinking. So with that, we're going to start with that. Ground rules are never sort of set in stone. It's not Moses comes down from the mount with the 10 ground rules that are then, forever. But we can craft these as we go through our 2 days together and see what's working, what's not, and return to them if we need to. All right? With that, look forward to working with you. We've got the first of the next pair of our presenters up. Jared.
Coffee? Thank you. Well, Manish launches the first slide deck. Just go right into Alex's slides and start it. Our first presenter, if you want to use a lavalier, wherever you are, back in that corner, they'll wire you up. And we need some sound with that. There's no sound.
Engineers will be different in the future.
What are the different cities we see evolving, and how can we really get an understanding of those cities? How can we immerse ourselves in those cities today?
What are the different social infrastructures, physical infrastructures that can be created in which we can all come together and thrive?
What's really important about looking at this through a world-building lens is that it is designed to look forward and then thread back into the present. The further out you look, the more it changes our view of the present.
We're literally forced to not only reimagine our communities, but to rediscover our neighbors, to rediscover many of the things that are right in front of us.
We're spatializing narrative and allowing the user to tell their own story as they navigate the experience of this virtual cityscape.
What can a megacity grow toward so that it's serving a better purpose? You start looking at individual buildings then, because you can typically shape a building. And can you connect several buildings together?
The buildings might form coalitions and interact with the utility, and the utility will interact with the providers of energy all around. That becomes a transactive energy system, and the buildings can play an active role.
I can design a microgrid that serves that district. Or if we need the microgrid to serve an adjacent district, we layer those together.
We need a water supply system that can meet 15 million people's needs.
Every building in the future should be capturing sunlight and rainwater, and every building should be recycling its own waste.
Ideally, the life cycle of infrastructure is one that is continuous or perhaps reused in the future without going back and re-emitting all that carbon to do the same thing over again. That's the way we've built over the last century, and we simply cannot do it anymore.
Buildings are not unlike a human body. They have bones and skin. They consume energy and regulate temperature and generate waste. What if architects use genetic tools from synthetic biology to encode the architecture of buildings right into the DNA of organisms?
The facades now become active components. And one active thing that facades can do, they can breathe or they can sweat.
You can infuse biological functionalities into structural building materials.
Almost 100% of all the controls in buildings are going to have some element of AI in them and machine learning. As you walk into the building in the morning, the building will recognize you by your electronic signature. You would have created a profile about your temperature, your ventilation preference, and then some of this microenvironment might follow you.
What would social cohesion look like in the city of 2070? I mean, it's reasonable to expect that it would actually be vertical.
So, going vertically also brings its own challenges in terms of safety and security.
You might have 175 drones coming in at 11:45 a.m. delivering lunch. Where do they land? How much space are between them? What are the specifications?
It just has to be designed in a way that people can interact, and making sure that you're encouraging paths of travel that are spontaneous.
We're at just the right point in time to get together and build basically the aerial equivalent of what we did in this country with the national interstate highway system, and no longer be restricted to 2 dimensions.
So how do you get the public involved in civil engineering, in the process of civil engineering?
One of the best ways that we can make sure that all voices are heard and included is to start with the people who are doing the planning and developing and see what their teams look like.
How can you ensure social equity and social justice and get input from the community for the projects that we're working on?
We are very conscious about the demographic, the diversity of the community and the society, and make sure that we don't leave anybody behind.
Creating these multi-use spaces is one way of doing that, of bringing people together. And once they're in the same shared space, there is more opportunity for connection, there's more opportunity for shared experience, there's more opportunity for civil dialogue.
The best solutions on Earth, they come with diversity of thought. What I love most about the Future World Vision Project is that we can think about it together. We can have this dialogue.
Users will encounter one another and have conversations across disciplines that will begin to feed back and bring new information into the system.
We're trying to build a world and trying to build a machine that is creating absolute engagement of the user and of the engineer in their own future.
The Future World Vision is really at the core of what we're trying to do at ASCE in transforming the idea of what a civil engineer can be. And that's how we think that we can advance the profession of civil engineering and attract the best and brightest.
Oh my goodness, this 4th Industrial Revolution, married to the fundamentals of concrete, glass, and steel, is this incredible toolbox for society. It's really on us as civil engineers to pull that all together.
So first, I think we need a round of applause for those in the room that had a cameo appearance. That was obviously one of the products of the contract ASCE did in producing Future World Vision that's been referenced. And a good setup for this morning's speaker, which is about storytelling and world building. We are entering a new era of immense digital tools that can provide more than just another new game. They allow us to shift to a multidimensional narrative framework. We can explore the entire ecology of a virtual world, a framework to ask new questions. You notice I love that phrase. Make sense of the complexity and uncertainty of the future world and consider the opportunities therein. 2 important things in world building, as we've done this with Future World Vision, and as our speaker will talk. These are my personal key takeaways, and that is, it is interdisciplinary in the extreme. You engage with people and perspectives far beyond your domain of expertise, and that allows you to think about the world you live in differently. And secondly, that world space is constantly informed by the human experience, the quality of life of the person. That's what Alex McDowell did for ASCE in the Future World Vision Project. Alex McDowell has been a production designer and creative director in film, gaming, animation, theater, and other media for many years. He is an originator of the narrative design system in world building, using storytelling for education, research, business, and entertainment. He is head of narrative design at Make Studios, professor of cinematic practice at the University of Southern California, and the director of the USC World Building Institute and World Building Media Lab. As I was making plans for the Future World Vision Project back in 2016, I met Alex through a Disney executive who told me how Alex had used world building in a film called Minority Report. And I think Alex will probably talk about it. And from that experience came Alex's world building discipline. Please welcome Alex McDowell.
Hi, good morning. Thanks, Jerry. Thanks for that introduction. I guess that's the reason I'm here, is that video we were just looking at. And thanks for inviting me again. So I should click this. This quote, I think, is sort of essential to everything we're going to be talking about in the next couple of days, but certainly it's been driving most of my work. And that is that we can no longer rely on the old stories that we've relied on for generations, centuries, millennia, because the world around us is massively changing, and there's no precedent for it, and there are no stories that we can rely on to support these changes now. So the question is, how do we develop new stories? This is my very crude version of the history of storytelling. Storytelling developed at the very beginning of our civilization as a way to make sense of the world around us. It also developed a way to communicate fundamental knowledge, that we discovered going into the forest, going up mountain in battle, in our families. Gradually, we learned more and more. And there was a tradition of oral storytelling which ingested all of those stories and then distributed them. First of all, horizontally, through societies, village to village, through communities. But most importantly, vertically, that generation after generation absorbed narratives, added more and more data to those narratives, more and more experience to those narratives, more and more knowledge. And then that was passed through generation to generation to generation. So I would argue that we're only here today because of storytelling. But in the 1400s, a massive change happened. The printing press dropped. And with the printing press came a packaging of knowledge, a way of creating a control over knowledge in the way that knowledge was distributed. And that applied through all of the crafts and all of the cultures and all of the ways in which we received information. So ultimately, we found ourselves in this proscenium relationship between the experts on the stage and the audience. And we were designed, we were put in the position of listening, of being instructed and waiting for that instruction. So for the past 600 years, that's kind of been what storytelling is. It's a linear process, and it's designed to hold on to these facts. The textbook, that we teach with is like, don't deviate from the textbook. It's going to be passed through generations, through through all of our time in school. And it's, laid down as law. So what we see is this translation from the script, the composer who publishes a script that is still being adhered to 200 years later by that orchestra, as opposed to jazz, where the coming together, as Jerry was saying, of radically different disciplines creates a 1 + 1 = 3 constantly, a constant evolution of freedom of development of ideas. So world building is an attempt to come back to that idea of oral tradition, of sort of full cycle. World building is naturally collaborative, it's naturally disruptive, and it provides a platform for us to develop ideas just as we are doing here today. This is a classic world building setup. It's a narrative design system, I'll just read this, apologies, for the creation of worlds centered on human experience. When we step inside these immersive worlds, these worlds that we become so familiar with that we understand our own future, we are already standing inside our own future, we can then understand where we're headed, thread back to the present, and change what we're doing. So world building is absolutely not about following trends, it's about disrupting trends. We also recognize that we have been the victims of a Victorian industrial system for those past at least 200 years, and that does not apply anymore to the disruption that we're facing and to the sort of the decay of those old industrial processes, that we have to work together, and we have to work together in an interdisciplinary way, and we have to work in a non-linear way to move these ideas forward. So what we're doing is, again, what we're doing today, a laboratory for how we evolve. And it requires us to use design, science, engineering, artificial and human intelligence to pull together all of the experts that we can. This is from a film that I worked on in year 2000 called Minority Report. The original premise was what if we can build a world that can predict the future? It's core to the narrative, to the story of Minority Report, if you've seen it. What was unique about this in media, in the film industry, because it is the script that gets the funding, that gets the film made, was that there was no script. But Steven Spielberg didn't really care about whether he had a script. He just got on with it. But he asked us to build a world concurrently with the writer. So over a period of about a year, while the writing was evolving, the world was evolving, which was unprecedented, and it flipped the model really of how we develop a platform for storytelling. It forced us to create a world from which the story would emerge. The other sort of primary directive from Steven Spielberg was this, even though it's set in the future, was not a science fiction film. This was a film that he wanted people to believe completely, that it was a future reality, that as people stepped inside it, they understood that this was a reality that could happen to them. And it's a cautionary tale, and therefore more powerful a cautionary tale because you believe it. So what that forced of us, in the normal making of film, you're moving so fast that you're just sitting in your room and pulling information to you. Luckily then, no internet, but increasingly being the knowledge being diminished by all of only what the internet gives us. But in this case, we were being pushed out into the world and into laboratories, into industry, into the places where that kind of fundamental research was being done that was going to inform this future. We had privileged access because of the names of the people involved. And we went into MIT Media Lab, and we went to DARPA, and we went to car companies and advertising companies. And as a result, Minority Report has this reputation of being one of, if not the most prescient films that's been made about the future. There are apparently over 100 patents applied to the ideas that came out of the film, and they were very broad. This is year 2000. None of these presentations of future existed at all. But it wasn't that we were being so clever, we just had deep access. And so we were seeing early research that was 15 years away from being put to market, but we had access to. And then because it's a film, we could package it as if it existed. And because it's packaged as if it existed, it is believed, and then industry starts going, well, if it's being made here, I can do that. It's a provocation. This gesture recognition system actually went into production 2-3 years later and is now a fully functioning piece of technology because it was funded because of the film and the research that was done for that. This is sort of part of the way, just as an example of our thought process. So generally, when we're building worlds, we're working with provocations. In this case, our provocation was, how does Tom Cruise get to work in the morning? We had the setup of this precognitive umbrella over Washington, D.C. that was creating a safe space from murder and from violent crime, meant an enormous ingestion of population to D.C., a new vertical city being built. Tom Cruise lives at the top of one of those buildings, and he goes to work in old D.C. In the police department. So we imagined or asked the question, what if you combined an elevator and a taxi cab? And from that provocation, we created a completely unique mobility system, which actually was a presentation of autonomous mobility. It also, in design terms, it had to move vertically and horizontally, so it created a very specific form that was able to make those rotational adjustments as it was moving through space. So we had the ideation from the provocation. Then we had manufacturing. We were going into some of the earliest rapid fabrication, certainly the first time in the film industry that rapid fabrication was used, TNC and casting for the vehicle, 3D printing for it to get approval, and then into previs. So we're designing the story before it happens, and then shooting it. And all of this was developed without the script. So in fact, the script adjusted to the possibility of this vertical car chase and would not, and that scene wouldn't have been in there if we hadn't had this open opportunity to develop it out of the world. The other thing that significantly happened, which changed my path, was that we stood back, maybe 2 years after the film released, I started to think and was being asked about the film, that actually, even though we'd only told one story, we'd told this linear narrative through that, woven through the world that we built, and the world was specifically designed to up-res around that narrative thread. We realized we could have taken this outside of media. We could have looked at the future of mobility, the future of advertising, targeted advertising, looked at cities and the development of cities and the development of technology. All of those things could have derived from that world. And so we realized that the larger world, the larger the worlds we build, the more capable they are of distributing or developing deep, complex, and multiple narratives. So to kind of harness that and to be able to process that, we developed this tool platform called the Mandala. And the Mandala is a multi-axis tool for ingesting knowledge and distributing knowledge. It asks questions that are fundamental to any set of problems that put in front of us. It asks, what's the ecology, what's the governance, what's the economy, infrastructure, culture, and the resources that were required for a world to develop. And it does it in scale. So we start off asking the contextual question, then in a metaphorical way, the city scale, the zone or the district, then into the street corner, which is the primary area where we work, because that's the human scale. That's where we begin to understand the relationships with people on the ground and as they relate to the context. And those human stories evolve from that. And then those human stories, as they develop, we push back into the world and they test the world. An example of this might be the pandemic. So we understand the context of the pandemic. We understand it at a global scale and understand it at an urban scale. and we understand it as a district scale and in the hospital and in the patient. And there's a push and a pull between that. There's patient demands, patient's outcome, patient narratives that push back on the government decisions. So there's a constant interplay between scales across all of these different categories. This is an example of a populated mandala. In this case, we were asking the question that relates to future world vision, which is how do you provoke the future of a new city? And we start off by asking questions. That's what the mandala is set up for. These kind of questions listed. We're pulling information into the mandala. It's a sort of storage system. And then we're scaling down into the street corner and getting more and more detailed. So in this case, for the development of a city, we can say, here are 6 street corners distributed through the whole city. They all have different conditions. One's commercial, one's industrial, one's residential. They all have different needs and different demands. What do we as humans, what do our human stories demand of the city through this investigation tool and then through the expression of it? As you saw in this film, we were asked to develop a world for future world vision. The radical question we were asked by Jerry and by the engineers was, can we look 75 years ahead? We'd never really been asked in an industry commercial space to look that far ahead. It's radical, and it changed the way we thought about. It changed the way we developed the questions that we asked for new cities to be developed and for a future that was going to be able to challenge the students that are going to be put into this provocation machine. So we started off looking at a floating city. This was sort of an initial provocation to open the possibilities of the discussions around the table, and it started that idea of working outside the pure engineering circle and starting to bring more and more people, particularly storytellers, to the table. But the provocation here was, what if Miami's insurance rates go up so much because it's flooding, 2 foot of sea level rise by 2050, that the population distributes and half of it goes inland, but maybe some of it goes out to the ocean, and there's already evidence of that happening. So we imagined that a city developed gradually over a period of 75 years that was floating, and then what conditions would we have to imagine for every aspect of that, from education to power systems to industry. And then we transferred that to the questions around the megacity, and really the fundamental piece of what is the future of alternative energy, climate change, autonomous vehicles, high-tech construction, new materials, smart cities, policy and finance. How do you ask all of those questions of where a future city may go? And then we developed that using game engine, using an engine called Unity, into a fully interactive world that is the ultimate provocation machine that's now at play in a number of universities. I forget, 60. Yeah. And here you can see there's multiple scales. So we start off at the city scale. We're moving around at that scale. We move in on the district. We move in on the street corner, and then we occupy the narratives on the street corner. And what the students are getting are questions, 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 provocations, provocations everywhere they go in the world. And that is hopefully changing the way in which you think about the future of cities. Totally different provocation. Why does Superman wear an S on his chest? He's from Krypton. They don't speak English. So we sort of took that, and actually it drove the entire film for us. We were asked, this is a film called Man of Steel, we were given an opportunity to build Krypton from the ground up. So we took this S, and it drove the entire process of the design and storytelling of the film for Krypton. Because we started thinking, well, if it's not an S, it's representing something that's highly organic. So what if we take that premise for the design system, we take the organic as a driver, we take the rule that there are no straight lines on Krypton, and then we have to develop everything, our sets, our spaceships, our clothing, everything is based on that premise, which is tricky because when you're working with construction, you know, a straight piece of wood is kind of the easiest thing. But luckily, we were deeply into 3D printing by then. And these forms that you see on the right are actually a fairly simple set of building blocks that happen to be parametric and asymmetric. So if you turn them, there are multiple different surfaces that they can provide, but they're built from the same, maybe 6 different forms. But that was kind of moving into construction, a combination of 3D printing again, or CNC cutting of these ribs. But we were working in Vancouver with a deep industry of shipbuilding that had applied itself to film construction. And so we were combining traditional methods and this 3D printing and constantly dealing or ending up with this idea of no straight lines. And then finally, we started asking ourselves what language might look like. This idea of the S being one of a series of glyphs representing leading families in Krypton, that there were many, many glyphs. And if there's many glyphs and those forms of those different family representations, what if we took that premise and developed it into an entire language? So in 3 months, we worked with a linguist anthropologist from British Columbia, and she developed a absolutely coherent language that if you have your Krypton dictionary, when you're watching the film, is all expressed in reality in the film. Again, a bit of a leap. This is sort of taking the extremes of a world. This is a world that we were asked to build by a scientist called Dr. Ray Stevens at USC. His issue was that, and Deborah referenced this yesterday, which was really interesting, that in science, in molecular biology, there's deep, deep knowledge. There are people who spend their entire career developing knowledge of 3 proteins in molecular biology and structural biology. And for him, the issue was the negative space between that deep knowledge. How do you actually start developing a horizontal knowledge as well as all of this deep knowledge? And his premise was, you can't do it alone. You can't do it just within the molecular biology community, if you like. You have to bring other scientists to it. And you bring multiple different provocations or pressures on that to start asking those questions. So we were asked to develop a new visual language for molecular biology that allowed a multiple set of people, different professions and crafts, to be able to talk to each other. The first problem was complexity. A single cell has around the same level of complexity as a big city. And the diagram on the top left is the diagram that molecular biologists understand clearly, maybe less so those people in the room. I don't know how many people here are molecular biologists, but there's a translation that we know from the city to the metro map, to the London Underground. It's a very clear parallel. It's very, very accurate. You can get to anywhere in the city, but it's a diagrammatic form of that negotiation, that navigating that complexity. And so we took that premise, and on the right there, that's a metro map of a cell, just 2 or 3 strands of the passage between insulin, glucose to insulin, sorry. So that set up the platform, the premise of how you negotiate these worlds. And I think it's interesting because you can say any one of those points, it seems simple, but any one of those points is giving you access to enormous amounts of data. So as with London, you go into the metro map, you come out in Trafalgar Square, and then you're in a real chaotic reality. The other problem was common language. So on the left, you have the complexity or a specific, it's not incomprehensible by any means, but if you put a number of different protein structured representations side by side, to the non-scientists, they look basically identical. So we spent 6 months looking at each other blankly across the table, and then realized that there is a common language, and that's the language of folding. That protein folding and architecture are exactly concurrent, and that Rosetta Stone was what allowed us to move forward. And then from the folding idea, we thought, well, how do you make that into a repetitive form, a set of building blocks? So we looked at the tetrahedron. Tetrahedron's interesting because it maps with the amino acid, the position of an amino acid in a protein comes directly from the coordinates of each amino acid in the protein data bank. And so we were able to say, well, those atomic coordinates can translate directly into the architectural coordinates, and we're getting close to something that is scientifically accurate and comprehensible. And then we moved this into virtual reality. This is now using the full breadth of storytelling craft to take those building blocks. This is GLP-1R, partially GLP-1, which has become more famous in the last couple of years. But this was one of many proteins that we developed. Each one is animate. Each one is showing specific behavior, specific interactions, reason for existence, relative scale. The relative scale piece was interesting. This is the first time any scientist ever had seen the actual scale between the nucleus and a GLP-1, for example, because there's no place you can put those side by side, because the difference in scale is something like the difference between a mouse and a mountain. In VR, that's a totally surmountable problem because you move through that space, everything is three-dimensional, and you start forming a relationship. The image on the left is a silhouette, something like a World War II airplane identification silhouette that allows us to establish unique identities without getting into anthropomorphism, making it look like silly things with faces. That this was creating a set of recognition tools that when we work with high school students or younger, they could form empathetic relationships with different proteins because they recognize them. So we kind of came away with this conclusion that what we had developed within a space, and this inner space, by the way, the word is because there's great interest in looking out and looking into outer space, very little interest apart from in the medical space to look inwards. And so children who are sick, giving access to the stories that are going on inside their bodies is a potent force in terms of storytelling. But we suggested that taking the metaphor of inner space is a forest, and a family goes into the forest, and the mother is a mycologist, and is getting down on her knees and examining the fungi and the mycelium. The father is an engineer and is looking up at the trees and taking inspiration in terms of structure, and the daughter is chasing butterflies. All of those things are completely possible all at the same time, all inside the same world. And I think it's a really crucial aspect of when we're talking about world building is it's very, very accessible and very fluid. So this program, which has been now a 5-year research program at USC, has become an education tool. We've had high school students learning at an undergrad level of molecular biology. We've taken this down to children as young as 5 or 6. And it's being used as a basic tool in undergrad molecular biology at USC, to the extent that they're now teaching storyboarding in the biology departments, which is something that when we started, there was no understanding that story and proteins even had a relationship. And so finally, and just very quickly, this is our process. This moves from mandala to prototyping in a very structural way. Once you get to prototyping, you decide what platform you're going to use. So we don't start off saying we're going to make a film or a game or a building. We start off saying, why does it need to exist? And what's the best form of telling its story? And that prototyping piece is sort of essential in the center. And then we move that out to outcome and move it to production at any scale. Just quickly, finally, do I have a second? You do. Okay. That's about the fastest I've ever gone through my deck, I think. It's all your fault. I hope it made sense.
All the speakers take note of how well behaved he was on the timing.
It's because Jerry was kicking me like this. Deborah asked a question last night that I may not remember exactly, but what problem do you consider to be the most important problem confronting you? About 20 years ago, I would say, I met a man who had been put in charge of creating a refugee camp in Syria called Zatari. It was a UN project. And what they did was put down thousands of containers in a perfect grid to allow the refugees to populate this camp. It started off, I think, with 50,000. It went up to 140,000 and then back down now. But the question that came to us, and the man who told me about this left the project because of this grid, essentially, because it was so inhuman. But mostly, what we discovered in our research is the average length of time a refugee spends in a camp is 17 years. That it goes up to 26 years. Zatari's still going, so the people, I think it started in 2018. So people are living there, and there's no visible end to that. So the question we asked is, why is a refugee camp not the foundation of a city? What would it take for us to reimagine refugee camps that are popping up, and constantly? It's not going to get any less, and the situation is just being gridded in a very inhuman way, with no prospect of a view to the future. So I consider our project, and I consider that all the jobs I do are part of the same single job. They're just funded by different people along the way. And that is to imagine how you create a city from the core that would normally, historically would have been the start of a city. People move towards a center, and it develops organically, and it develops gradually from a village to a town to a city. So why is that not happening? It's because our structure is absolutely not equipped to do that. Our governance is not equipped to do that. We're not thinking organically. We're not thinking in terms of storytelling. So if we were to look at what do people need when they come into a refugee camp, how do you build a completely new premise for a refugee camp with a view to a city that devolves just like the floating city might have, then it's an aspect of what we can do that would create enormous change. Thank you.
Alex, I'm going to ask you to turn your mic off, but keep it on. We're going to bring you back up if we have some time for Q&A after the next presentation, okay? All right, and I'll let you do it, but we've talked about these principles of interlocking systems, multiple societal, technological, environmental, and political influences, and a systems-oriented construct. But they've already begun to influence our approach to engineering, design, and delivery. Our next presenter will describe how the rapid growth of BIM and visual tools allow us to make investment decisions, improve multi-party design and construction dynamics, reduce delivery times and costs, avoid project owner frustrations. None of you have experienced that, I'm sure. Reduce unplanned changes and improve engineering profit margins. Craig Russell recently retired from a long career with Walt Disney Imagineering, where he led major projects worldwide and co-led the studio for almost a decade as the Chief Design and Project Delivery Executive. He will be talking to us about a special project that embodied these integrated design and delivery principles, the Star Wars exhibit at Walt Disney World. I just met Craig last year by referral from one of his former employees, and yes, Craig, I asked you to participate despite what he said. Craig now advises architectural, engineering, and construction companies and themed entertainment leaders on improving company culture, organizational vibrancy, and process innovation. Now, he is also very active with social housing nonprofits, as well as local wildfire recovery efforts near his home in California. And unfortunately for us, just a few days ago, those efforts in wildfire recovery have developed some critical local government meetings that are happening today, and hence Craig cannot be with us in person. However, we will hear from him virtually. Craig, you're on.
Thank you so much, Jerry, and good morning, everybody. I'll add to the apology that I'm really sorry. Obviously, I intended to be there with you in the room and participate in all the discussions, and some meetings just ended up landing on this afternoon that are critical between LA County and about a number of business leaders. So what I'm going to spend this time doing is sharing a story about the sociology, some of the mechanics, and more importantly, the sociology of pretty significant change and innovation that was pressed and then ultimately, I think, in hindsight, failed at Walt Disney Imagineering over some period of time. It'll be a story about virtual design and construction, which is pretty commonplace today, VDC. But wasn't 15 years ago, and also the merging of that with a methodology of partnering with designers and builders called IPD, or Integrated Project Delivery. So I'll get to that in a minute. I'd like to share a video that sort of introduces Walt Disney Imagineering and its practice and some of its uniqueness. So we'll roll that video and then I'll get into the story.
When we dream up new ideas for Disneyland, they first take shape and form in preliminary studies. These scale models and the drawings and the blueprints. These are the things that dreams are made of.
Will you marry me? Okay, so that's Walt Disney Imagineering in a nutshell. When I look at the practice, and I've been engaged in it for 45 years, so I understand it pretty deeply. If I compare it to sort of a more traditional or conventional AEC owner business, it stands out in two ways as being pretty unique. It is geometrically usually pretty complex, a lot of organic shapes, as was explained by our previous speaker, and some of the same complexities there. And also it's highly integrated. It's not uncommon to have 45 different design constituencies in the room when we're integrating design together. So it's it's a team sport, and it's much of its complexity and much of its cost is driven by that integrative complexity. As my role when I was co-leading the studio, which, by the way, in Imagineering, just to be clear, is charged with the ideation, conceptualization, design, and execution of pretty much everything physically that you would visit with Disney, whether it's an attraction, theme park, cruise ship, resort hotel, etc. So any place that Disney makes is really the charge of Imagineering. As co-leader and leader of design and project execution, I essentially was the chief innovator of practice and process to fight the complexities of our work and the cost basis of our work, which was growing constantly. And this will be a story of one such innovation that we pushed very, very hard, and sort of the arc of what we learned. Next slide. Years 2010, if I rewind to that, to sort of set up what it was like at that point in time, Imagineering, WDI had its project menu was growing rapidly, near doubling in terms of capital project scale over the following 6 to 10 years. There was a mandate that we set to increasingly leverage outside partners so that we could keep our own team somewhat sustainably set near 2,000, close to 2,000 people globally as we could. Imagineering has historically had an inconsistent and sometimes challenging reputation in the market. Its work is complicated, it's hard driving, it's uncompromising, and it has been seen historically as pushing to shed risk onto its design and construction partners, which is just a reality. That reality carries with it quite often pretty significant bid premiums that much of the marketplace places upon the work. Within our group, there was an inconsistent investment in design and integration of design, which caused an inconsistent level of quality of the design product as we entered into production and construction. At that time, at around 2010, there was a rapid growth of BIM and virtual design and construction tools in the marketplace, which created a big opportunity. Both within Imagineering and above Imagineering, senior leadership, there was a fair amount of frustration with not only project costs, which were growing, but the rates of unplanned change, unpredictability in the process, which really had less to do with, a lot of people thought it was because it's a creative organization, which it is, but it had more to do really with the imperfection of design than just random creative or operational change. And happily for us, there was a tremendous amount of risk tolerance in the leaders above us to do things to push against these factors. Next slide. So we set up as a team a rationale for a different approach, for combining and intersecting virtual design and construction with integrated project delivery. We wanted and set out to evolve our reputation toward a win-win partner. We wanted to, and in quite a few cases, built very successful partnerships with AEC players who prove that they are willing to drive the project over the self-interest of the company. WDI had to do the same and had to learn to do the same, in kind. We pushed a virtual design and construction mandate to realize the project before we set out to the job site, something that was not in our culture. People love to run out and start building. And we said, no, we're going to completely build it in the machine before we build it on site. We intended through this investment to make a significant improvement in both our lifecycle schedule and unplanned change. We intended to force all of those hidden AEC partner contingencies above the line so we could see them and drive to minimize them. We wanted much greater flexibility in our procurement, and especially in construction. And we were used to having to deal with general contractor claims way beyond the project completion, and we wanted to get rid of that. And we wanted to get rid of also the waste that happens when the owner designs a project in its mind perfectly, and then the contractor and subs and other suppliers often redesign a fair amount of it through the shop drawing process. And then overall, just to improve the quality and predictability, not to mention safety through VDC management. Next slide. So the strategy was pretty straightforward. We started by, we were not up the curve on either integrated project delivery or virtual design and construction. We recruited industry leaders. The practitioner who was a world-class leader in IPD from Universal Health, a world-class leader in VDC who came on board and taught us really a different standard of virtual design, and then moved on to Gensler and is currently their chief digital officer. We socialized up and down our own organization, not only the mandate but the objectives, the why, as it were, of the initiatives, and confirmed that our leaders above us were tolerant, would have tolerance towards the uncertainty and evolution that would ensue as we pushed these things. We made deep investment ourselves in learning what the industry was doing. People who were ahead of us in this, Lean Construction Institute was really instrumental into that, and we formed our own industry partner coalition, our own little small LCI, as it were, primarily in the two sites that we work in Southern California and Florida, with industry partners, to learn together about both virtual design construction and IPD. That included, as an example, taking quite a large number of partners, contractors, trades, consultants with us to our cruise ship builder in northern Germany, who is at the time was truly the world class and was relative to modular prefabrication, essentially building an 1,100 foot building that lays down and floats, and realizing it completely before it's built, and then treating it as sort of manufacturing a car much more than building a huge project like that. And then we very importantly set out to identify projects as pilots that would increase in scale and complexity, and also that we would push ourselves deeper into the swimming pool relative to the models we used to learn. Next slide. That led to the project that Jerry referred to, that I consider the big bet in this big push towards virtual design and also IPD. We had pushed smaller projects, maybe $200-300 million projects, with these models pretty successfully, and this project landed on our lap, and we decided to go way deep into the swimming pool and push both VDC and IPD. Next slide. The project was a big assignment from our CEO, who had just acquired Lucasfilm, to create the largest single land expansion in the history of Disneyland. Next slide. And for extra credit, to recreate it, to create it simultaneously at Disney World in the third park there, and do so with only a 3-month offset, so very little time to learn between projects. And next slide. And do so in a record short amount of time for something this complex and at this scale. Next slide. So what this represented for us is a very complex project from both the facility perspective as well as the sort of theatrical disciplines, the show technology, the ride systems. They're highly complex, and from an AEC perspective, large scale, well over $1 billion worth of construction. Next slide. So a few slides on just kind of the what we did, the mechanics. We had been, as we approached Star Wars, pushing models that are considered tri-party in IPD terms, where the owner forms an alliance and a essentially joint venture with the GC and the designer, usually the architect, under whom then the trades and the other sub-consultants are connected. For Star Wars, we moved to a poly-party agreement, which is going to involve many more partners, including the owner, certainly designer, general contractor, but also a number of key trade partners and consultants. Next slide. So if you look at it, just think of it as a risk-reward pool that you push people into the pool when either they represent enough value or enough risk to the project to want them in the pool of, essentially in the joint venture that shares risk and reward. And then there are other partners, either design or fabrication or construction, who may be outside of that pool, who are connected to either the GC, the designer, or the owner. And so it's a matter, the way we were taught to think about it is, you're on the island alone, and you gotta live. So you as the owner vote the second person on the island, and it may be the general contractor, maybe the architect, and then the two of you vote the third, the three of you vote the fourth, et cetera. And then collectively you vote. If somebody's going to be voted off the island, it happens sociologically the same way in reverse, that the people on the island have equal votes. Next slide. The way this actually materialized for Star Wars is in this kind of diagram. Disney, and I hope the print's not too small, but I can sort of explain it. There are 16 parties that were signatory to this joint venture deal. Disney as owner, but also as designer. So Disney had to be one of three architects as a democracy, not as the leader per se. There was a general contractor for both East and West Coast, Whiting Turner, who did a spectacular job sort of helping us innovate this. And then around the planet, there were a number of trade subcontractors and consultants where we could have one for both coasts. We did. Where we could not, we did not. And so this group of people together signed up early on to design and build the project together as a joint venture. Next slide. I could go way too long about the sort of financial mechanics of this, but to just summarize it at a high level, the way it works and the way the incentive and the motivation is supposed to work is at the base, the owner agrees to pay all of the direct costs, reimburse all direct costs in full for all partners, design partners, build partners. Above direct costs, there is risk. There's contingency and allowances that aren't known that aren't known at the time you set a target. That sits above that. Above that sits profit, which is called an incentive compensation layer, or ICL. Above that sits ideally the opportunity to maximize or improve profit over that ICL. And the goal is to dramatically improve the profit over time, because the owner and the partners all win for every dollar of profit that the partners increase. And then at the base, if some models have some of the profit guaranteed at the base without being put at risk. So that's essentially how the money and the incentive works. Next slide. And then another important aspect of this is that we set as a team a charter at the beginning. We had a number of different aspects of that charter that we measured every quarter, and we held this one very important. We set a goal relative to this notion of putting the project success as of paramount importance, and whether people felt that was really the way the behavior was working throughout. And you can see we set a goal of 7.5, and we achieved well above that throughout the process. And these were confidential We shared them out to everybody, but they were confidentially scored. Next slide. So outcomes and then lessons. The pluses and deltas. The pluses were significant, and they were pretty much what we, for the most part, what we hoped to achieve. There was a significant life cycle schedule improvement. Arguably the most complicated attraction and facility that we've ever realized in our history was built from the first stick of steel going up to a temporary certificate of occupancy and commissioning shows and rides that are already installed in 26 months. That was upwards of a year faster than we'd ever been able to move. We had a material reduction in unplanned change, which was a huge goal. As hoped, the incentive compensation model did push the partners to be solution oriented and to innovate, and to not just think of their same, self-interested ways of working. There were no claims. By definition, the way we set it up there, in a way there wouldn't be claims, but there weren't anyway. We had complete open book visibility to the costs, much more flexible and agile sort of and seamless relationship between design and execution. And then, simply stated, the greater the collaboration and the greater the decision-making efficiency caused the project to be a lot less stressful. At the end, we had a dinner with all 16 and just so, rate this as in level of fun and stress. And I think either 15 or 16 of us said the most fun, the least stressful project we'd ever worked on at scale. Next slide. There were some deltas. Despite, this model requires you to set a target that then the profit is based upon. And despite everybody's best attempt, and it was really the owner's obligation more than anybody, because we're the ones who are the most knowledgeable of what the project needed to be. When we set the target, we set it too early, and the scope grew, the costs grew after that, and we found that the knock-on effect of that is that the profit pool was going to erode to nothing very early on in the process, and so we had to make a decision. We didn't have to contractually, but we needed sociologically to make a decision to re-up that profit pool to essentially to keep the incentive that we intended to drive with this. Obviously, that cost us money, so that was not, that was a delta. We set out so earnestly to co-locate everyone in Glendale, California, to design this thing together. And we erred in quite a number of cases, bringing design trades as well as building trades into that mix way early on, and we that proved to be inefficient. We wasted time there. Obviously, the partners got paid for it, but we wasted owner time and resource there. That all of this rigor and transparency around change management was great, but it required a whole bunch of administrative support, and it was quite administratively burdensome to keep up with it, because there was a massive issue resolution log, so that we didn't get changes to the point where they started costing a lot of money. So it was very effective, but it was burdensome. And if you just zoom out of look at WDI, it does lack despite the fact this was very successful and all 16 partners said they'd do it again in a heartbeat, WDI doesn't have this fantastic regular hospital, one hospital after another menu that allows you to learn together and keep a team together to optimize a process over time. Next slide. So to me, the most important part of this is kind of the lessons that we learned from it. As I said at the top, at the end of the day, I see this as something that ended up being a failure. And on the one hand, everything I've told in the way of the story probably sounds like at this point in time, we've on balance built a fair amount of momentum towards sustaining these this innovation. However, there was a significant change in senior leadership above us. My partner and I were moved to the side, and that leadership made it clear that the risk tolerance and appetite for innovation were going to change dramatically. It was much more about predictability than it was about pushing for better. There's a reality that both virtual design and construction and integrated project delivery require you to make a lot of upfront investment, which is a bet on non-guaranteed project outcomes, which is the speed and the lack of change and lack of of claims. And so I defy any of us to prove at the beginning the value of the mistakes that we don't make in a project that would then rationalize that upfront investment. So that's complicated, I think, sociologically with the team, and as a result, project team leaders were in the position of taking short-term individual risk for the long-term benefit of the collective of the entire studio to change its reputation and become world-class at this. Next slide. We did a great job of rationalizing and socializing up and down the chain of command, the mandate and the objectives. We did not do a great job of addressing some of the broader studio cultural aspects of this, and certainly we did not set up a clear reward structure that made absolute clear, on the one hand, within the profit pool, there was a great reward structure, but within Imagineering itself, we did not set up a reward structure that made clear the intended outcomes of this sort of pushing this innovation. WDI, it's a great thing, but it's a curse. It's a consensus more than a command and control environment. So that made adoption trickier, and certainly when things changed above it, it led to significant resistance once the drivers for the change were maybe not removed, but certainly diluted. And then outwardly, those partners who seemed quite willing to come along with us and push this innovation, once they detected our lack of will to really push it as hard, they pretty quickly reverted back to business as usual. So, on balance, we learned a tremendous amount. I think we made some very good progress that probably the studio builds upon today. But if I just look at this as something that wanted to say the Star Wars project was going to have the next that we're going to build upon, that simply did not happen. This fell away within a couple of years of the Star Wars project as being something that was primarily pushed. And I think it was because the sociology more than anything else. And next slide. With that, I'll simply suggest that we're interested in your thoughts and any questions you might have.
In the spirit of time, we're going to get a very limited opportunity, because you will have most of these speakers with you again to talk with them, ask questions throughout, but since Craig won't be, let me ask Alex to come back up. But I'm going to take 2 questions for Craig while he's coming up, and then 2 questions for Alex, and that's it, so we can stay on schedule. And Kyle, thank you for your forbearance on that. Any questions for Craig first? Okay, one there, and then one over here.
Thanks for the presentations. My question is about design versus, can you hear me okay?
Yeah.
My question is about design versus analysis. And it sounds like, the design process is of necessity sort of under-constrained relative to an analysis process, where we typically go and we run tests in the lab, or we do a mathematical proof, or we run experiments. When it comes to doing analysis, we usually have a set of criteria that we're trying to satisfy, and we like to say that we're transparent about those, and we can measure and do all this other great stuff to show that we've done the analytic process correctly, or at least in a way that's consistent with those criteria. On the design side, it doesn't look quite that way, and I'm wondering what guides you through the design process? Is that something that we need to worry about formalizing or verifying so that when we're done, we can say, oh yeah, we can show that we've captured the requirements, we've satisfied the requirements that we set out to fulfill? I hope that question makes sense to you all.
Yeah, that question makes a lot of sense, and for our practice, I'll kind of go back to the sociology, and I'll talk a little bit about what the tool set today allows. On on the one hand, WDI has way too much sort of legacy history of having its project management leaders be fantastic builders and want to rush to execution. You can kind of go back to Alex's talk a little bit of just running to execution without the proper level of design and analysis. When I was co-leading, I was pushing very hard for the project managers, who are the leaders of the entire enterprise, to come out of design, because we blow $4 out of $5 in design. We just find them in construction or find them in manufacturing. And so I was looking, hard at that balance. I think if you look at the tools today, it's, in my mind, at the risk of oversimplifying, there's no good rationale other than impatience and a lack of investment in design and integration, not to fully realize the project in the machine before you go build it. There's no reason you cannot do that with the tools that we have today. So to me, I see at Imagineering, and I think beyond, the project manager of the future changing, the construction manager of the future changing towards people who are design centric, probably analysis centric, and less, in a way, building centric, because they know this notion that you do blow $4 out of $5 when you're sitting in some quiet conference room before you go to the field. You just find them when you're up against the rigors of the field. I mean, it's not. I'm explaining Japanese lean methodology in a different way, right? So certainly something in AEC.
One more question over here.
I don't think. Okay, yeah. This is Rob Mueller with NASA, and we are building a moon base, and it's not dissimilar to your Star Wars exhibit, except it's the real thing. And this always frustrates me that you get big budgets to build a Star Wars exhibit, and I can do the real thing for the same budget. So that's just a personal frustration, but we're going to solve that. We need help from the AEC industry with new business models and methods. Turns out the engineering is not really the hard part of building Moonbase. The hard part is what you were talking about, is how do you get people to work together in an incentive-based environment, and what are the business practices that are required to make this happen. We are going to build a moon base, and we're in a moon race, but we can't use the methods of the 1950s and 1960s to build such a moon base. It's not sustainable. It's not going to work in a business model, and the government doesn't have the funds to keep it going for the next 100 years. So we need help from this community on how to. We're talking past each other. I wrote a paper with a glossary, a lexicon of translating. We have a preliminary design review. You have a feed, a different word for it. It's like we're talking past each other. So we need help on how to work with the AEC industry in an incentive-based environment that's highly collaborative with a lot of digital engineering. So my question for you is have you captured everything that you just presented in some kind of a paper that I can start passing around internally at NASA?
The answer is in one coherent paper, no. And I'm probably frustrated to answer the question that way. We certainly have captured it in terms of presentations like this. And I guess maybe something that we can build off of is that there are a couple of people who certainly remain at Imagineering who are highly skilled in the legal and sociological aspects of this, who I think would be certainly very interested in working to develop that. So again, it goes back to the unfortunate reality that you push the leaders aside who are. This happened with a couple of different leaders I was working with in the Lean Construction Institute. Once the catalyst for change was pushed aside, and if there wasn't enough, if the culture wasn't built to withstand the pressures, the new pressures upon the organization, the interest in this model, in both virtual design and construction and integrated project delivery, waned quickly. So there was not a lot of organizational push toward this. Obviously, virtual design and construction has moved in the industry so rapidly that a lot of this just has become commonplace. I'm personally shocked that integrated project delivery is not more commonplace in the industry.
Okay, with that, I'm going to give Alex equal time. So just two questions for Alex. First one's here, and second one's going to be back there. And then he'll be around to chat with at other times.
Thanks, Alex. I'm Krishna Kumar from UT Austin. When you're building the Minority Report world, you have constraints of our real world, or your world models, our world building is based on constraints that you inherit from our reality, compared to the Krypton world model that you built, where you did have constraints which you were able to define, like no straight lines. When do those worlds come alive to you, and what has each of those world model building under different constraints has taught you about what the other is missing?
Yeah, it's a great question. Thank you. So because in all cases, we're really trying to project forward into an unknown space and then investigate that and allow the stories to emerge from what we discover. I would say we approach every project in the same way. We've just finished a year of very large-scale urban development, and that is the equivalent of building Krypton, honestly. It's probably as silly and fictional. But actually, I don't know if I'm answering your question. Can you tell me the bits that I'm not?
Do you notice any big differences between building worlds where the constraints are inherited versus constraints are defined by a smaller set of people, where you still have to have constraints in building these worlds?
Yeah.
And can we learn from each other? Is one more creative and allowing you to dream bigger? Maybe assuming Krypton let you do that, then can we bring those ideas into the real world, our world, and as we project forward in that?
Yeah, absolutely. The first step we always take, and in a sense, as soon as we look forward any amount of time, we're really in a kind of fictional world space, because anything can change, is that we build a set of constraints regardless of whether it's for reality or for fiction. And they are very rigorous. They're based on the initial provocation, and then it's a big part of the design process is actually to say what constraints are going to accurately frame the solutions to the problem. And I think in this sort of, the mandala, if you like, is a constraint model. It says that it is surrounded by rules, and everything that develops from that has to be working with those constrained rules, and it's absolutely applicable to anything. But I think that what we're looking at and what we're going to be talking about, I think, is that everything we're dealing with is subject to change, and the rules that we're looking at now, we should consider, the possibility that things are not going to be the same in reality as well as they are in fiction. So, yeah, I think that process of research and ingesting knowledge, and then the back and forth with the constraints that you then develop and understanding they're fluid is common to all of the projects we do.
Last question right there.
Thank you. Stefan Straub, World Bank and University of Toulouse. So I was very interested by your first figure where you show this kind of evolution of the storytelling as as structuring the story of the world in a sense. So I was thinking, I never thought of it this way. So you say the printing press arrives, and then we have this technology that is very directive, that kind of implies political control, and from there, all the stories we get are from books, TV, radio is the same, and we get stories, but we don't have a possibility to provide feedback. And then suddenly the internet arrives, and then that's a new technology where not only we get stories, but we can also say something back, right? And I don't know if that's the right interpretation. Is that what you have in mind when you say we're changing regime? In a sense, we're going to this world building type of environment, or is there something else at play there? What is it you think are the main determinants of this transition and this new world in which we are now?
Yeah, I make a distinction definitely between the sort of feedback possibilities of internet and social media and world building as a process, if you like, because I think that we rapidly devolve into chaos when we're in this free-form feedback. And if we look at the comparison between the oral storytelling tradition, for example, in world building, it was highly defined. There was a hub and a distribution of node points that were very fluid again, subject to great adaptability, being able to push out to any number of different places. But nevertheless, it's within a pretty disciplined structure. And I think that we are very careful to make a difference between what world building is when we're recruiting, if you like, the most coherent thinkers around a specific problem. And it's absolutely scalable. We've done this with 300 people. We've done this over a period of a year and over 3 days, et cetera, et cetera. But it's the thing I would say about the internet and the changing technology in terms of communication, let's say, or transaction, is that it does give us a set of tools which are really valuable. Knowing that we can work within this very fluid setup within world building, using the technology, it's what now AI is becoming really useful for us, is that it's allowing us to create a more multidimensional framework of transaction and interaction, and be able to say there's another player in the room, if you like, or several, but it allows us to take those ideas further. But basically, yeah, it's a very disciplined discipline, very systemic. And I think it somewhat refers back to, I think, the first question, just quickly to react to that, which is, I think what we're trying to do with world building is we're creating a narrative core, which is understood to be to do with emotion and empathy and relationships and stuff that is not easy to define or capture. Within the system we're developing, we're trying to find ways to be highly analytic without compromising those emotional, empathetic centers. And so bringing technology into close relationship with this storytelling development is what we're doing when we're doing urban design. We are absolutely discovering stories, and then they're reverberating through the construction of a master plan. It's very, very specific, as it is with the molecular biology project I was indicating, which is there is the need for an emotional core, but it has to be scientifically accurate. And that's a fascinating piece to me of what we're all developing in this very broad, now collaborative new spaces, and the relationships that we can have between art and science and engineering and architecture and art is unprecedented. And it's got everything to do with an acknowledgement of analytics and systems and the need for human core, and how do we bring those together.
Join me in thanking Alex and Craig for being with us today. We're good. We have blown right through your break, so we'll see how kind Kyle will be to you or not.
Well, before we take the break, a couple logistical things. One, we're blessed in having a real good set of demographics in terms of attendees at the session, ranging from gray-haired people like me down to, the emerging professionals coming from the school in particular. But we want to make sure that there's distribution of those young voices around the room. And I've at least been cued that there may be sort of a cluster of them as opposed to a distribution at this point. Is that a fair observation?
Can I make a comment about this?
Yeah.
Yeah, so